All right, welcome back for Chapter 4, Lesson 10. We're going to talk about transforming linear functions. So when you talk about transforming, this really leads into what's called transformations. And today we're going to talk about 3 different transformations. The first one we're going to talk about are translations, which is just something like if I have this and this is my line, it's a line that's staying in the same place, well, the same kind of direction. It just shifts up or it shifts down. That is a translation. So yeah, shifting up, shifting down. That's going to be the translation. And then the other thing that we're going to talk about are going to be rotations. And that's if we have a line, and then if it's like, have you ever like seen the spinner, right? And you go and you flick the spinner, and then the spinner just spins all around, right? Well, that's rotating, right? And so it could be here, and it could be getting less steep, or it could be getting more steep. And so that's what we're going to be talking about, is just rotating. So imagine I stuck something in here and I could just spin it and it just spun around or it rotated around. Okay, so that's the second thing, is rotations. And then the last thing we're going to talk about are reflections. And all of these, okay, second thing. Third thing is reflections. And a reflection is just when it's this way and then it reflects across a line, or like this. If let's say I need a line. Where's the line? Oops, sorry, that. So like if this is my line, right? Like my hand is like a reflection. So this is being reflected over there, or kind of like a mirror, right? So we're gonna kind of look at that concept graphically. But what you need to know is we're talking about transformations and 3 different types of transformations: translations, rotations, and reflections. So with all of these, we are going to be talking about f of x. We're going to be using function notation, and you'll see why in a little bit. So f of x equals x. Remember, f of x is just the same thing as y. So it's saying y is equal x. This is called a parent function, and this is so important. So this f of x equals x, which is the same thing as y equals x, is a parent function. And it's for the family of linear functions. And basically, it's just the most basic, simple function there is. This is a line, right? It's so simple because what's the slope? The slope is 1. What's the y-intercept? It's 0. So this is just the most basic linear function equation that there is, and that's why they call it a parent function. Okay? So when we are talking about translating, we are going to be changing the y-intercept, which will shift it up or down, and that's called a translation. So these 2 pieces of information are really connected. Translation, that didn't work. Translation and changing the y-intercept. Okay, so that's really what we're going to be looking at, is that y-intercept, and if that y-intercept is moving. And if it is moving, if it is changing, then that is a translation. So we are going to graph the parent function here, f of x equals x. So that goes through the origin here, and so I'm going to graph that. Hopefully I can get it all in the same shot. So this is right here. So the y-intercept is 0, right? The slope is up 1 over 1. So that is the graph of the parent function. This is where we are starting. We are starting at the most basic. And you notice how there's 3 lines? So if I said y equals x and y equals x plus 2 and y equals x minus 4, it would be hard to differentiate between the 3 lines. That's why they use function notation. Because instead of saying y equals x, y equals this, and y equals that, I can say f of x equals x. G of x equals x plus 2, right? This is the same thing as y equals x. And this is the same thing as y equals x plus 2. And this is the same thing as y equals x minus 4. But if I say h of x, you know I'm talking about this equation. If I say g of x, you know I'm talking about this equation. If I say f of x, you know I'm talking about this equation. So really this whole function notation is really super helpful when you start talking about multiple lines because it helps identify the lines very quickly. If we didn't have that and we just had this, I'd just have to be like, you know, y equals x minus 4. So you'd have to say the whole equation, whereas I can just say, hey, h of x, and you know exactly what I'm talking about. So we're going to graph these. We start here with the parent function. When we go to g of x, what do we notice? What is the difference between g of x and f of x? Well, what do I see? That we have a y-intercept here. So this y-intercept was 0 for the parent function, and now it's plus 2, which means the y-intercept is now 2, right? And then up 1 over 1. So this is our g of x here. And so what happened from the parent function to the g of x? So from f of x to g of x, what happened was it shifted up 2 units, right? That shifted up. They're parallel lines, and it shifted up 2 units. So we were at 0, and then it went 1, 2, and now we're here. And so you can tell that the y-intercept was 0, and now it's 2. So that's how you tell the translation, right? So it's the change in the y-intercept. So the y-intercept went from 0 to 2. So that means that this is a translation that shifted 2 units up. Okay? Now let's look at h of x in comparison to f of x. So h of x is x minus 4. So here the y-intercept is negative 4. So we're going to go down here to negative 4. And then the y-intercept is up, the slope is up 1 over 1. So we have our, this is h of x here. And this was h of x. Okay, so what happened from the parent function here of f of x to h of x, right? The y-intercept was 0, and then what happened? This parent function shifted down 4 times to h of x, and you can tell that by the y-intercept, because here the y-intercept for the parent function is 0, and now the y-intercept is negative 4. That means that this shifted down 4 units, so that it translated down 4 units. So this is how you're going to do problems. You're going to start with the parent function, and they're either going to shift up or they're going to shift down, and when they do that, you'll see that difference in the y-intercept. And so just by looking at this and comparing these two, I can see it's 0 here and 2 here. So this is a translation, and it's shifting up 2 units, which is exactly what happened in the graph. And this one, if I compare the parent function to this one, it has a y-intercept of negative 4. So it went from 0 to negative 4, which means this line shifted down 4 units. It translated down 4 units to this one. Okay, so that's basically what we're going to be doing with these first couple problems, talking about translations. So what we're going to do here is we're going to graph f of x equals x and g of x equals x plus 3, and then describe the transformation from the graph of f of x to g of x. Okay, can you tell what's going to happen just by looking at it? Like, what's the y-intercept here and what's the y-intercept here? Can you tell what's going to happen? Okay, let's just graph it. Okay, so the first one, f of x equals x, so that means that my y-intercept is 0, and then my slope is up 1 over 1, right? So I have my graph here. Okay, and this is my f of x equals x. And then I'm going to graph g of x, which is the y-intercept is plus 3, and then the slope is up 1 over 1. Okay, so this is my g of x. Can you tell what's happening? This translated from here to here. What happened? Well, it translated up. This line translated up 3 units, and you could totally tell because of the y-intercept, right? So what we would say is we would say that f of x translated up 3 units to g of x. And that's our answer. All right, perfect. Let's go ahead to the next one. And I want you to go ahead and try this one on your own. So here's my friend the pause dragon. Remind you to pause your device. Go ahead and work it out. When you get done, press play and we'll talk about it. Okay, let's see how you did. So we have f of x and g of x. We have f of x equals 2x, and we have g of x equals 2x minus 5. Now, this isn't a parent function, right? Because it's not f of x equals x, like this one. This was the parent function. However, this can still have a transformation. What do you notice about this? Do you notice something? Well, let's go ahead and graph it and then just look visually and see what happens. So f of x equals 2x, our y-intercept is 0, and then the slope is up 2 over 1. So I'm going to go ahead and graph that. Okay, this is my f of x equals 2x. And then I'm going to graph the other one, which is, what is it? The y-intercept is -5, and then up 2 over 1 is the slope. Put that like this. And this is g of x equals 2x minus 5. Can you see that this is a translation? And it translated down how many units? Right? The y-intercept was 0 here, and now the y-intercept is -5. So f of x translated down 5 units to g of x. And that's our answer. Perfect. All right, if you got that one right, awesome job. All right, and I'll see you in a little bit for the next example.